A number keypad has 10 buttons with the numbers from 0 to 9 on it. You need to press the buttons to unlock the door with a security code. Each security code consists of 3 numbers. A. How many security codes could be made? B. If the same number cannot be repeated, how many security codes could be made? C. All 3 buttons are pressed at the same time. How many security codes could be made? In this video you will learn definitions and some examples of power, permutation and combination, how to solve a simple question using tree diagram formula, and how to solve a harder question solved with formula only. Power, first of all, has repetition and order matters. We could use this example by making a 3-digit pin, and those 3-digit pin examples could be 001, 121 and 918. Now, you can repeat, but you don't necessarily have to. In permutation, you're not allowed to repeat, but order still matters. We could use an example by picking 3 cards, 1 card at a time, from a deck of 52 cards. There are the symbols heart, diamond, club, and spade. So, the first card, we could have a 8 club, then a 9 heart, and a 7 diamond. But no matter which one you pick out, there will be only one with a number and a symbol. So you will only have 1 8 club, 1 8 diamond, 1 8 spade, and 1 8 heart. Now, for combination, you can't repeat and order doesn't matter. This could be used by selecting team members. So I could have in my team Lauren, David, Ava, and Odin. But no matter what, even if I selected them like Odin, Ava, David, and Lauren, there would still be the same 4 people in the team. The other 2 examples are shown below. The simple question is, how many different 2-digit security codes can be created from this keypad? To help with the formulas, what is N and R? N is 3 in this question, and it is the number of choices to choose from, in this question the number of buttons. Now for R, in this question 2, it is the number of objects or elements to pick from, and in this case the number of digits of the security code. If your security code can have repeated digits and order matters, then we are going to use that power to solve this problem. First, I'm going to show you how to solve power with the tree diagrams. For the first digit, we could have 0, 1 or 2, which are our 3 choices. Then for the second digit, remember, you can repeat, so we still have 3 choices, 0, 1 and 2. Using the formula, which is n to the power of r, or in this case 3 to the power of 2, this would equal to 3 times 3, and that would be 9. So we would have 9 different security codes, which are these 9 different security codes. In a second case, if we had no repetition but order still mattered, we would be using permutation. In a tree diagram, for our first digit we could have the 3 choices 0, 1 and 2. But for the second digit we would only have 2 choices because we're not allowed to repeat. So if we chose 0 first, we would only have 1 or 2. If we chose 1 first, there would only be 0 or 2. And if we chose 2 first, there would only be 0 or 1. Now solving this question with the formula. The formula would be n's factorial over n minus r's factorial. Now for those of you who do not know what a factorial is, go and check out my Terminal Zeros video as it explains what a factorial is. So in this question it would be 3's factorial over 3 minus 2 factorial, which equals to 3 times 2 times 1 over 1 factorial. Now, 3 times 2 times 1 and 1. Have you noticed that 1's factorial is 1 and also there's a 1 on the top? So we can cancel those two numbers and we are left with 3 times 2. 3 times 2 equals to 6. And this is because we have 3 digit choices for the first digit and 2 remaining digit choices for the second digit. So we have 6 different security codes. In a third case, if there is no repetition and no order and we are pressing the 2 buttons at the same time, then we will be using combination to solve it. Instead of the first digit and the second digit, we are going to be using button 1 and button 2 as order doesn't matter. So we could choose 0 as our first button that we are going to press, and then we can press at the same time we can press either 1 or 2. This could form 0 and 1, 1 and 0, 0 and 2, or 2, 0. Now if we choose 1 first, we can only choose 2 to press at the same time as we cannot repeat, and 1, 0 is the same as 0 and 1. So our only combination is 1 and 2. If you wanted to solve it with a formula, NCR, or in this case 3C2, you would have n's factorial over r's factorial times n minus r's factorial. In this case, it would equal to 3's factorial over 2's factorial times 3 minus 2's factorial. This would equal to 3 times 2 times 1 over 2's factorial times 1's factorial. 2's factorial is 2 and 1's factorial is 1. That means it would be 2. We can cancel the 2 at the top and we can also cancel the 2 at the bottom. So we are left with 3 times 1, which equals to 3. There are 3 different security codes we can make in combination: 0 and 1 or 1 and 0, 0 and 2 or 2 and 0, and 1 and 2 or 2 and 1. Now we are solving the harder question. Remember, we have a keypad with 10 buttons with the numbers from 0 to 9 on it. Solving this question with power. A. How many security codes could be made? The formula is n to the power of r, which in this case is 10 to the power of 3, or 10 times 10 times 10, also known as 10 cubed. 10 to the power of 3 is 1000. In this question, in the case of power, the answer would be 1000. Solving this question with permutation. Having no repetition unlike power, but having order. If the same number cannot be repeated, how many security codes could be made? The formula is n's factorial over n minus r's factorial. In this case, it would be 10's factorial over 10 minus 3's factorial, which equals to 10's factorial over 7's factorial. If we had written them all out, we could cancel the 7, the 6, the 5, the 4, the 3, the 2, and the 1, with the top and the bottom. So we would be left with 10 times 9 times 8, and that would equal to 720. If we were to solve this question using permutation, the answer would be 720. Now if we solved it with combination, no repetition and no order, it would be C. All 3 buttons are pressed at the same time. When I say this will mean that there would be no repetition and no order unless you have 2 buttons of the same type. It has no order because no matter what, Even though you press those 3 buttons, it will just be the same 3 buttons you pressed. The formula is n factorial divided by r's factorial times n minus r's factorial. This time it would equal to 10's factorial over 3 factorial times 10 minus 3's factorial. This equals to 10's factorial over 3's factorial times 7's factorial. We could cancel the 7's factorial with the top, but we are still left with 3's factorial. So in this case, we could also use the permutation divided by 3's factorial. It doesn't always necessarily have to be 3's factorial in any other question, but in this case it is 3's factorial. So our answer would be 720 divided by 3's factorial, and that means our answer is 120. If you were to solve this question using combination, you could make 120 security codes.